So here in this video, I want to show you the Laplace transform of some of these standard signals. Okay, we have discussed most of these in the previous videos. So here this is just a brief brush up so that you will be able to memorize all these coming signals. These are some of the important signals that we are using to do our problems in Laplace transform. And these signals are very important as far as from the examination point of view is also concerned. Okay, so here the unilateral Laplace transform of some of the standard signals is what's shown over here. So this is a unilateral Laplace transform. That means the Laplace transform, the integration starts from 0 to infinity. Okay, unilateral Laplace transform. All right, so in other words, so for example, if you look over here, the Laplace transform of del of t is equal to 1. Okay, this is the first equation you have studied. The second equation is the Laplace transform of u of t is equal to 1 by s. Or in other words, the unilateral Laplace transform of number 1 is equal to 1 by s. Okay, here it is written that the unilateral Laplace transform of L of t is equal to 1 by s square. You can write it like this, or this is also equal to the Laplace transform of t into u of t. Understood? This is also equal to the Laplace transform of t into u of t. Okay, so likewise, this is the unilateral Laplace transform of e raised to minus at is equal to 1 by s plus a, or you can also say that the Laplace transform of e raised to minus at u of t is also 1 by s plus a. You see, this L represents unilateral Laplace transform, whereas this L represents normal Laplace transform. So in case for normal Laplace transform, then you have to multiply that given signal with u of t in order to make it unilateral, or in order to make it causal signal. Okay, so here also Laplace transform of cos ohm 0 t is equal to s by s square plus ohm 0 square, or in other words, this is also the Laplace transform of cos ohm 0 t into u of t. Okay, here the Laplace transform of sin ohm 0 t is equal to ohm 0 by s square plus ohm 0 square, or in other words, this is also the normal Laplace transform of sin ohm 0 t into u of t. Okay, likewise, this is the hyperbole cosine transform, hyperbole cosine function cos ht. Cos h ohm 0 t is equal to Laplace of cos h ohm 0 t is equal to s by s square minus ohm 0 square, or in other words, the Laplace transform of cos h ohm 0 t into u of t is equal to s by s square minus ohm 0 square. And the last Laplace transform of sin h ohm 0 t, hyperbole sine function, sin h ohm 0 t is equal to ohm 0 by s square minus ohm 0 square. It's nothing, this is also equal to Laplace transform of sin h ohm 0 t into u of t. Okay, into u of t. Okay, so this is basic standard signals you have studied. Once if you have studied these basic standard signals, then you will be able to do almost any problems in Laplace transform. Okay, and one more thing also I want to tell you, very important, is that you should simply not only learn the Laplace transform, but you should also learn the inverse also. For example, if this is the Laplace transform of this, then you should also understand that the inverse Laplace transform of this is also this. That means looking at this, you should be able to write this, and looking at this, you should be able to write this. You see, back and forth is also very important. That is also required when you are, especially when you are doing the problems based on finding the inverse Laplace transform. Okay, so now with these signals in your mind, we'll be doing the properties. Okay, so make sure that you have studied each and every one of these unique formulas. Once you have studied all these formulas, then the coming Laplace transform equations and problems will be very easy for you. Okay, so now let's move on to the properties of Laplace transform.